Now, the method of sections is very helpful when trying to find the internal forces of a structural member. It especially helps with making it easier to find the forces in specific members. You can sum forces in the x and y directions and take moments, and you can have up to 3 unknown members. Let's look at this example problem. Here we have a simple truss, and we have some loading on that truss and some distances. And we're just asked to find the resultant forces in members BC, BE, and FE, which if you notice is right in the middle. First off, it's a good idea to find any of the force reactions going on the truss. So let's go ahead and do that. We know that since there's a pin reaction at A and a roller reaction at G, we can solve for those unknowns first by looking at the structure as a whole. We can then sum forces in the x and y directions and take a moment to find the unknowns. I'll take a moment about point A, and these are our equations. I'd first solve for the moment at A because I would be left with one unknown, which is the normal force at G, and then I would sum forces, and these would be our answers. All we need to do now is make our cut at the truss. We can make a cut that is straight through the object like this. And then with this cut, we can look at either the left side or the right side. I'm going to show you what both look like right now. This is the right side, and here is the left side. As you can see, they both contain the unknowns we are interested in. We can choose one or the other to find our answers. I always ask myself, which is easier? I look at the diagram and think that the one with the less forces is always easier. Knowing that, I would say that the top one that shows the right half of the structure to be easier because it only has 2 forces acting on it, where the left half has 4 forces. Now we can look at finding the sum of the forces in the x and the y directions and take a moment about a specific point. Before we can sum forces in the x and y directions, we're going to need to find the angle of that diagonal member, BE, which we will call theta. Then we can set up the equations for summing forces and taking moments. We can use arctangent to help us find that angle. Then we should take a moment about the point, which will eliminate the most unknowns. Where do you think that is? Well, I would take a moment about point E, because it will take away member BE and FE, and even P2. Then we will only have to worry about BC and P3, because they're the only ones acting on that moment. Next, I would sum forces in the y direction, because BE is my only unknown in that direction. Finally, I would sum forces in the x direction and balance out everything. And these would be the answers for the tension and the compression in those objects. Now, many students have always asked me how I can know something's in tension or in compression. How I look at these is I assume that they're always in tension initially. If you notice, all BC, BE, and FE initially were assumed to be going away from their respective points. That is tension. But when you make the assumption of tension and something comes out negative, that means that your assumption was wrong and that they're actually in compression. And since I found that FE is in compression and BE and BC are in tension, I have my final answers.